So whatever we observe in block diagram form or in circuit form, right? So that can be seen in terms of the PCB here. So here you can observe the trigger circuitry here, right? Final amplifier here, Y amplifier here, right? As well as the different power supplies in the extreme high tension. So this extreme high tension is covered here because we have to produce a 10 kilovolt, and this 10 kilovolt is nothing that is capable in moving a train engine, right? So that's why this section must be protected, right? And this extreme high tension very high value of the voltage of 10 kilovolt, 15 kilovolt, depending on the required CRT, right? So that's connected to the neck of the CRT, right? And why it is connected to the neck of the CRT? Because the three alternating anode and the translating anode are capable in moving the electron for a particular distance, right? But electrons do not have the sufficient energy that those can cover the vertical direction of the CRT, so the vertical direction of the CRT. So this is why when they pass through the vertical side of the plate, they must have sufficient energy to cover the horizontal and vertical direction of the CRT screen. So this is why the post-deflection oscillators are used, and those post-deflection oscillators are connected to the extreme high tension of 10 kilovolt, 12 kilovolt, or 15 kilovolt, right? So the extreme high tension is connected to the plate of the CRT, so that the electron will gain the sufficient amount of the oscillation because of the created field, and you can move the electron in vertical and horizontal direction, and the required signal can be produced on the CRT screen. So now let us start with the front panel, because whatever you observe in the circuit form in the demonstration kit of the CRO, that can be seen on the front panel of the CRO in terms of the different switches, right? So we have the tube-based CRO. Tube-based CRO means we use the two channels, and a single electron beam is used to show both the traces, right, or both the signals. And these two channels are denoted by the channel 1, which is also the representative of the Y, because the test signal is connected to the Y terminal, right? And finally, after the processing, that signal will go to the vertical side of the plate. Similarly, the channel 2 is a representation of the X. The signal connected to the channel 2 is represented by the X, the horizontal section, because if you apply the signal to the channel 2, that will be finally connected to the horizontal side of the plate. With the help of the coaxial cable, we can apply sinusoidal, triangular, square, or any time varying signal on a DC signal, right? So coaxial cable RCRO probe is used here to connect the signal. Okay, when you want to measure the AC signal or a DC signal, you have to select the proper knob. Similarly, if you look at the time for division for the channel 1, as we are using the two channel CRO, right, as well as we are using the dual test CRO. So for the two channels, we have to use the two separate volts for division here. So here you can observe a particular range of the voltages, that what is the minimum voltage or what is the maximum voltage that can be measured with the help of the CRO, because CRO is a measuring device, right? CRO is an inverse transducer, CRO is an electrostatic device. So everything must be measured in terms of the voltage only. And if you look at the volts per division here, so what do you mean by this volts per division? That the number of divisions in vertical direction on the gratitude means the CRT screen is multiplied by the volts per division, and finally the division by division can be cancelled, and you will find out the corresponding measured voltage with the help of this scale, right? So earlier we discussed that this volts per division is nothing that has multiple volts, means it is used for the amplification of the signal. If the signals are too weak, it may be used to replace or mean attenuate the signal if they are out of the screen. So the purpose is solved with the help of the volts per division. So that's why the volts per division is not only a switch to provide the strength to the signal. This is also used for the attenuation of the strong signal. Strong means the signals which are going out of the CRT screen. Similarly, if you look at the dual test CRO, so definitely dual test CRO has a single electron gun assembly, right? So a single electron gun assembly is available, and the single horizontal section which has a horizontal amplifier as well as the time-lapse generator, as well as the Schmitt trigger, RC attenuator. So these are all connected to the horizontal section. And how the horizontal section of the CRO is represented, so that representation is done with the help of the time per division. So whatever shift signal you generate with the help of the horizontal section, so that is seen in terms of the time per division, and that is used for the synchronization of the test signal that you apply to the channel 1 to the Y terminal, right? So the signal is synchronized with the help of the shift signal, right, or Sawtooth wave signal. And if doesn't have the same value of the applied signal, right? So the value must be varied. So with a stable signal, that may be sinusoidal, regular, square, or any form, must be stabilized on the CRO screen, right? So the task can be completed with the help of the time per division. That means the applied phase signal must be synchronized with the help of the time per division switch, right? So time per division switch is nothing, that is the representation of the switch signal, that how the signal is generated and what should be the value of that signal, right? Okay, the another role played by the time per division is this is used to measure the time of the signal which is terms are shown in the horizontal scale of the CRO, right? So number of horizontal divisions are counted and must be multiplied by the time per division if you are observing the fixed signal or the stable signal on the CRO screen. So the horizontal division is multiplied by the time per division of that signal. So you find out the time, and finally if you take the inverse of the time, you find the measurement of the frequency of that signal. Okay, on the top side you are able to observe here certain switches like the X1 to X5. Okay, X1 means the signal is shown on the screen, and if you want to magnify this, so press this switch so that you can find the magnification 5 times on the screen. So this is X1 to X5. Similarly, we have the XY. The second switch is denoted by the XY here. And what is the role of the XY? That when you want to apply the signal to the vertical channel or to the vertical amplifier or to the test terminal, and if you want to find its resulting, right? So in that case, you have to press the switch denoted by the XY, so that the vertical line can be seen irrespective of the type of the signal on the screen. So the vertical line is nothing, that is the peak to peak voltage that can be observed whenever you press the XY switch. Please also remember that pressing the XY switch doesn't mean that every time you get the vertical line only. So this is true for the signal when applied to the channel 1 only, right? If you are applying the signal to the channel 2, then the horizontal line can be seen when you press the XY switch. So if you want to observe the signal connected to the channel 1, so there is no need of pressing the switch denoted by the mono and the dual here. But when you want to observe both the signals connected to the channel 1 and channel 2, right, connected to the channel 1 and channel 2, so in that case dual is pressed, the switch is pressed so that both the signals can be observed on the CRO screen. There are two modes of the CRO. One is the alternating mode, another one is stop mode. So if you want to read the detailed description of this alternating and the stop mode, so please go through my slides. We have earlier shown later with the help of so many signals, so please go through those slides. Now look at this another switch located on the front panel of the CRO. So the switch has two arrows, one in left direction, other in right direction. That means the movement of the electron can be done in left and the right direction with the help of the switch. Right, so this is also known as the X movement. The CRO can be synchronized with the help of the internal signal, with the help of the external signal, or with the help of line. Right, so that's why the three switches are observable here. If you want to provide the triggering with the help of the internal, so that is done with the help of the applied signal itself. Right, if you want to trigger the horizontal section or the trigger generator or the switch generator, so that is line signal can be used for the triggering. Right, and the switch can be generated. Similarly, if you are applying the external signal, so that can be also be used for the triggering operation. So internal, external, and line switches are available here on the front panel. So depending on you, which type of signal you want to use for the synchronization of your applied phase signal. Right, so the signal can be synchronized based on which type of trigger you are using: internal trigger, external trigger, and the line trigger. If you look at this another switch, that is denoted by intensity. And I think everybody has a knowledge about it, how the intensity can be controlled. So whenever the electron is generated with the help of the CER with the cathode, electron is generated with the help of the cathode. So that is moved in the forward direction with the help of the control grid, right? How many electrons you want to pass through the control grid will depend on the electron numbers, and those numbers will form the electron beam, right, after the control grid. So if you have the more number of electrons, it means the more intensity. If you have the few number of electrons, it means low intensity. So the brightness is controlled with the help of the control grid. Okay, look at another switch denoted by the focus. Okay, there are two types of focusing can be done in the CROs. So if you look at the state of the pre-splitting anode, so after that we have the focusing anode, right? So how to focus the electron beam on the CRT screen? That is done with the help of the focusing knob here. Okay, the focusing has another name also, that is known as astigmatism. the normal, so norm mode or alternating mode can be selected here. Labeling operation can be done here, triggering can be done here. Signal can be inverted with the help of the this invert I and V switch. So if you have the signal coming from any source on the CRT screen, right? So the signal can be inverted with the help of the invert switch, right? Okay. For all the signals, right? For all the signals, we have different control switches are available here, and with the help of these other control switches, we can observe the stationary pattern on the CRO screen, and we can measure the frequency as well as the voltage with the help of the CRO, with the help of the switches. So thank you so much. If you have any doubt, you can write a question in my WhatsApp number.